Welcome back, everyone. Our next talk will be presented by Marko. Marko is a backend engineer at Solflare with a decade of backend engineering experience. He now builds web3 products at Solflare, which is one of the world's fast-growing crypto wallets. He'll share how his team achieved a 20x performance while cutting infra costs by 90% during a massive web3 bullrun. During that bullrun, they were serving 4 million monthly users and securing $20 billion in assets. So without further ado, please give a warm welcome to Marko.
Thanks, everyone. So, as a colleague mentioned, in order to achieve all of this, the backend needs to work flawlessly. So we'll go over a couple of things today, what we did to actually support that. But before we start, let's get around to getting to know each other. So let's see how many of you have ever used any crypto wallet, hold any digital assets. Cool, cool. And how many of you are engineers, front-end, back-end, whatever? Okay, majority. Any DevOps folks? Cool. So why I'd ask that? Because some problems that we face in the Web3 backend systems is mostly similar with the Web2 scaling, performance. So even if you're not from the Web3 world, you can relate to some of those topics. Okay, before we start, let's discuss about one thing. What actually is a Web3 wallet? A lot of people are comparing that to some banking application where you check your balance, manage your money, sending different not tokens, but yeah, on fiat currencies. So the biggest difference in a Web3 wallet and a banking system is in bank everything is centralized. So the bank owns the servers, everything is in their hands. You need to follow the strict procedures that are defined by the bank. You are limited by the opening hours of the bank. So if you want to do something on a weekend, and if you want to transfer abroad to some other bank on not in your currency, you need to wait a lot of time. In a Web3 wallet, you are the holder of your keys, which means that you are your own bank. Nobody controls your assets, and everything is stored on chain. So that is the biggest difference between like traditional banks and this Web3 space where you are the owner of everything. So wallet is actually proxy to the blockchain, which allows you to do everything, in this case, in Solana. Solflare was the first wallet on Solana, but despite that head start, the competition is huge. So we constantly need to roll out a new feature, ship fast, because users in this space doesn't have too much patience. And if you have some issue, some slow load, some bugs at crucial moments, this user is probably lost forever, because it's not like somewhere else when you need to like open the account in the new bank and like go through the procedure to activate the account, transfer everything. You just import keys into another wallet and this user is gone. Okay, so what we are serving in reality. This is more than 1 million daily active users, and those users are not only the ones that are like only opening the application or doing anything with it. Those are actually the users that are interacting with the chain, meaning transferring some tokens, exploring the new ones, transferring stocks, swapping, doing the staking, which is like earning passive income from staking of some of those tokens. And this translates into 2,000 requests per second, which is not the biggest that we have. This is like a normal day, not in a hyped market. And everything there needs to go through our backend, which is around 3 million daily crypto transactions. So yeah, pretty huge. But what happens when the bull market hits? So Solana hits the new all-time high. Trump is launching the coin on Solana chain. So everyone is waiting there to like for some airdrop, to mint something, to explore new tokens, new opportunity to earn something. There is a large platform called PumpFun, which is responsible for making, gives you ability to pretty easily launch a new token. At that moment, they will releasing 80,000 new tokens a day, which is mostly like new token every second. And what happened to our backend at that moment? Those are the messages in our incident report Slack. Some of them are in Serbian, I'll translate them. So the previous service that was handling 2K requests per second now is on 5K. We have a lot of spikes in the metrics. Those requests are happening out of the working hours, in the morning, in the night. We have a lot of delays. So we have actually the two incident reporting systems that are calling us if something goes wrong. And usually it was in the middle of night that you see that your phone looks like this. This is literally how the backend team looked like at those moments. So yeah, the firefighting phase. Basically, we were digging through logs, seeing what can we catch, what gone wrong. Introduced OpenTelemetry stack to see better what is happening, to understand what was wrong, to see the metrics and traces. And at the end, we scaled a lot. So to understand how we reached this point, basically, we need to see what was the initial idea in the infrastructure and the architecture of the application. So when the Solana was in the early days, as I mentioned, everything was on the chain. There was no need for some proper data storage. There were not too many users, not too many transactions. Everything was stored there. So basically, how the system worked is in the request response cycle, if the user requests something, we see if it's in the cache, and then if it's not, we run to the chain, pick it up, prepare it for the next request, and return it to the user. This was pretty good at the beginning, but then when everything exploded, Redis was a huge bottleneck for us. There were no clear separation of concerns of the services. So even we had an idea and we have multiple services that should be responsible for the different things. At the end, most of the things were landing to the one huge monolith, which was serving 90% of the traffic. And most of the time it happened that during the huge load, since this service was not responsible for only one thing, when the user hit some critical request, it experienced the delays because something is happening in the background. So for example, we are fetching the list of tokens, on some cron job to update all of the tokens that were visible in our application. So at the beginning, it was a couple of megabytes, tens of megabytes. After that, a couple of hundred of megabytes. And everything of that is stored in Redis. And from the previous two, this issue came naturally. So I mentioned maybe we are using the Node.js for most of our backend services. So experienced a large event loop blocking. And basically this didn't came from a thing that we didn't delegated, didn't push the things to run in the background. It was not a problem with the code that we've written, but actually how the things are working on the layer below. So yeah, I mentioned the huge token list stored in the Redis, no separation, that is blocking the event loop. Can you maybe guess or have the idea what was actually the problem here? Sorry? It was not caching, but actually you could relate to that, but a much simpler thing. So basically in the Redis, everything was stored in the key value pairs, and those huge list of tokens, since you want to work with them, you need to parse them. And it's not like the happiest thing for the node to parse the 200 megabyte JSON array. So yeah, and then some painful topic, which is scaling. Basically, we had an issues on multiple fronts. We didn't know for sure if the issue is only with the code, the infrastructure, the networking, because spikes were happening not always on the same thing, but all across the app. And this, for example, how the scaling of one of the services looked like. So at some point of time, we have more than 2,000 instances of one service. And if you circle back, we had like around 2,000 requests per second. So at some moment, we basically had a request for instance, which was crazy. So the only happy about it was our Cloud Run provider, because those are the costs for 1 month, not even fully finished. And most of the costs are going to this blue line, which is Cloud Run. And for that, the scaling is responsible. So we're basically throwing money at the fire to stay alive and like spending around $500,000 a month just to keep our app running. So we knew the problem is not like easily solvable. We need to rethink take a step back and rethink it, what the issues are happening, not just in like on every part of the application, but to see what are the crucial parts that are causing this. So okay, we decided Redis is not sustainable anymore. We need a proper database, and for that, basically any database that we can query, that we can filter, that we can find the things that we only need and not everything at once. The second issue for the no clear separation of concerns is to split the things in the jobs and the services. So basically, the jobs will do the things in the background. It will enrich the things in the database, and some of the services that will serve the API will just do and pull out those things and serve it to the user. It will not be too many calculations and fetching in the request-response cycle. And the third problem that we have is fixed by simplification. So basically, if we manage to fix the first two, the third one, it will disappear by itself. So how we decide what to do? So the biggest issue that we have is with the tokens. Tokens that are visible in the application and the list that was constantly growing day by day. So we decided that the most crucial thing should be enriching of the tokens, because you don't have everything at one source. So how it works, you pull up the price from one place, some things are going from chain, you pull out the other things off chain, and then you merge everything and it's ready to be seen by the user. And once everything is enriched, it could be served to the user via token service, which is only reading those things. So choosing the right database was like not a tough decision, because we just needed anything that could do the job at this point. So basically, we created a small proof of concept to choose between Postgres and MongoDB. And for our cases, it was pretty similar. So we decided to go with Postgres, because we already have some portion of the things stored in the Postgres, for example, for analytics. So that was the database that we chose. Now the question was, should we store everything in a single table, or should we split the things to be like in multiple tables? As I mentioned previously, the prices, the metadata of the token, it could be everything in the same table or separated. Since we were pretty read heavy, we didn't want to have a lot of joins in the place when you are like pulling the things. So we decided to go with a single table approach. And now orchestration of those jobs. We had like a couple of them. And since they had a pretty like distinguished things that they were responsible for and clear separation, we didn't need anything like super fancy that will orchestrate them. So we decided that the cron jobs, schedule trigger cron jobs will do the trick. We choose between like going with queue trigger jobs or maybe Cloud Run triggered jobs. And most of the stuff were already on the GCP, so we choose the simpler approach that is out of the box there. You just connect the trigger to some specific job and it will run. And this is how the initial architecture for that looks like. It's pretty small and complex, but basically those are the 12 jobs that we started with. On the left side, you have the scheduler that is going to that are going to trigger some of the jobs. Some of them were more crucial, some of them not so important. So we had run every 30 minutes or run every 10 or 5 minutes. For some pretty crucial ones, like for example for the prices, we had them run every single minute. Some of the jobs are pretty simple, doing only the ETLs, and the other had some internal queues, doing the multiple stuff, pulling the data from chain, off chain, and storing that to the database. We'll go over some of them to see the idea, but actually this approach was pretty good because we started with only 12 jobs. Now we have 30 of them, and the system is working fine. So yeah, here's the example of one of those jobs, off-chain metadata sync. So as I mentioned, everything is stored on-chain, but actually you have some stuff that you need to pull from Web2 servers. Why is that? Because the memory on Solana is limited, and you don't put everything inside there to save the memory. So basically what is the standard now is that you store some of those metadata like image or some additional things for the token. You store that on some servers. And then you just point the link to the chain data. So when you're pulling that, you're storing the link to the database in our case, and we have some flags to see if the metadata is updated at. So basically, on the left side, we have the source that is the database, and producer is pushing those tokens inside the queue. And on the other side, we had a consumer that is actually trying to fetch the metadata from that URL that is pushed to the queue. So we had multiple consumers in the parallel running to fetch those things, because those servers are not always active. Some of them are dead. Some of them had a huge delay to return you the response. So in order to speed the things up, we spin up a lot of consumers that will finish that and avoid fetching one by one. And with that approach, we were able to finish this thing in I don't know, tens of minutes instead of days. Some other job that is super important for our system is swappable sync. What swappable means is basically the tokens that you see in the app that can be exchange for some other tokens. That is what swappable flag do. And here the important thing to understand is how the APIs or the data sources in the Web3 works. It's not like a traditional Web2 API where you have a documentation, you have ability to fetch the specific things that you need to paginate to only get the updated stuff. Basically what happened here is from the external, we are getting the list of the swappable tokens inside one huge array in a response. So basically, this is millions of tokens, hundreds of megabytes array that we need to store. This was our initial idea how it should work. Everything is in transaction because you don't want to have the portion of time when you see in the app that something is swappable or not. That should be the opposite. So, okay, you update all of the tokens first that are previously swappable to non-swappable. And then after you fetch those millions of tokens, you update all of them as a swappable into the database. In theory, that works. But in reality, this was the only thing that we saw. That happened when we deployed that to the Cloud Run. Do you have a clue why? Sorry? Yeah, well, it was a single transaction, yeah. Everything run into the same transaction, but you're on the right track. That was kind of the issue, but exactly, yeah. we had a lot of deadlocks because the Postgres engine in the background was trying to lock all of those millions of tokens at the same time, and probably at that moment of time, for some of rows, something else is happening by some other job. That's the price that we need to pay because we chose the single table approach, but yeah, this was not something that was working. So we rethink it a bit. And the idea that we had is to introduce the staging table, the table that will only leave once the job is run, and after that it will be cleared. So what is the idea is to fetch all the tokens from source, put it in that staging table, and with two pretty narrowed down and simpler queries, where you update one table by one query that is atomic, which is looking for the content in the other. So you have two methods that are doing update of the non-swappable and updates to swappable. So basically, we filter everything out. If it's swappable false, then do the update. So we don't update on everything, and then just see if this token exists in the other staging database. Similar here for the tokens that should be set to swappable, only update them if they are not, and if they exist in the second table. So yeah, with this we managed to fix the issue with the deadlocks, and then the deployment phase came. This is what one of my colleagues said. It's like, do you actually have a better testing ground than production, especially when you have the huge airdrop? So basically on Solana you have those airdrops when teams or companies are giving you the free stuff, and when that is happening, everyone is waiting for claiming their airdrop, and the traffic is increased. It was not actually like that. We had some staging testing, but the load was not near the one that we had on production. So we pre-filled everything, we let the jobs run for some time to fill the database, and then step by step we updated, gradually roll out the update for letting the traffic bit by bit to use the token service. And at the end, it was pretty good. So what we learned at the end. Postgres is super nice. So at the beginning, we had 2 million of tokens. Right now, that's around 10 million, and it's handling things pretty fine still. The important thing is to do indexes properly. So, for example, most of the things in our system happened only on swappable tokens. So we introduced partial indexes to increase, decrease the index memory and improve the queries. Also, one special case, which was when we used the gin index to improve the free text search. For example, there is ability in the app to search for the token by name or by symbol. And before that improvement, you need a couple of seconds to get a response from database. After that, it was a couple of hundreds of milliseconds. We managed to do do the indexes properly and everything that is optimizing the queries because of the explain. So basically, we run all of the queries in the on testing phase with explain to see what is actually Postgres doing in the background, and there we were able to fine tune everything because performance queries were super important for our case. Yeah, because I mentioned previously, transaction is not an option because of the single table approach, and we need to be careful with that. And since we had write-heavy jobs and read-heavy token service, which is serving the request from the user, we decided to go with a read replica, which will be connected only on token service. So we also separated those two. Yeah, cron trigger jobs are underrated. You don't always need a fair and fancy orchestrator, additional thing to manage to take care of when you have the clear separation and responsibility of the jobs. Some simple cron triggers will work. That is what was in our use case. And yeah, scaling isn't always scalable. So when your system is super bloated with a lot of stuff that it's doing, not separated, not like it doesn't have the clear responsibility of the things. When you scale, you only like try to survive, but actually the problem lies below. So that's what happens with us. And the user experience when we scaled was not better. It was just keeping us alive. So that's why we need to redesign underneath. And yeah, what previously was 2K plus instances is now handled only by the 30 instances of the token service. For sure, we have the jobs that are doing in the background, but that's like a portion of the cost. So what we achieved in the end, so we had much better response times and up to 20 times faster. For sure, it's not all of the endpoints, but some of them were like much faster. We had a ton of tokens. Previously, what I mentioned, that token list that was stored in the Redis, it was like triggered once an hour to update the token list. And when you have the new tokens, what the traders like to see it immediately in the app, so they can buy it early. And with this approach, we were able to have the multiple ingestures that are loading the tokens into the database. And after the token is launched, you can see it in our app in less than 300 milliseconds. And regarding the costs, from $500,000 to peanuts, because we don't need to scale that much anymore. We are much more in the controlled environment. Of course, we have the auto scaling and everything, but not as near as previously. And what is the most important thing? The PagerDuty doesn't wake us up in the middle of the night. We can sleep much better. That's it. Thank you.
Do we have any questions? Here's one. Just let's wait for our volunteer with the microphone.
What's the time frame from when you realized we have to change our logic to actually pushing to production the scaled version of the backend?
Okay, so we knew a lot of time that something is wrong, but from actually when we started, I think it was around 2 or 3 months, something like that, 2 months.
Thank you.
Hey, any more questions? Okay, here.
How exactly did you set up the cron jobs? Was it part of some pipeline? Was it manual work? Did you improve the process over time?
Yeah, so basically at the beginning, we had like Cloud Run jobs and you set the trigger manually. Basically what we did later on is because not only on swappable service we see deadlocks, it was happening on the other places as well. So first what we did is like do the delay of a cron job. So basically if some jobs need to run, I don't know, every 5 minutes, don't run it actually every 5 minutes. Next one will be run after 1 minute, but 5 minutes. So to have those shifts. We don't have the pipeline yet. We have some scripts that help us to deploy because this thing doesn't change too often. When you create a new service, new job, you just set the trigger there. But we have the script if we need to redeploy everything to set everything up automatically. But right now we don't have any like complex pipeline that will do that for us. For sure, for the future, that's the plan, but we didn't reach that phase yet.
Thank you.
Here we have in the first row.
So you moved from Redis to using Postgres. Do you use Redis to some degree in the application?
Yeah. Sure, Redis stays there, but not as a main layer of for a data source. So we use bullmq a lot, which relays on Redis. We also do the Redis for some other caching purposes, but not storing the whole list of the token inside. So we even moved to a Dragonfly for the performance reasons, but we are still using the Redis. It's not like deleted from our app. It's like addition to the token layer.
To continue the question, why did you choose Redis in the first place? Did you not expect to get to the threshold of it, or?
Yeah. I think that was I was not there from the beginning, but why that happens is because from the early days of Solana. There were not so many tokens, not so many transactions. Everything is on-chain. You can always fetch the fresh data there. You don't need to store a replica of it inside your data store. So it was we were not ready for like that huge growth because okay, it's happening over time, but when the bull run hits, everyone is there and you experience it the most at that moment. So
okay, anyone else? Let me just check if somebody asked through the app, maybe from online attendees. Anyone else? If not, thank you, Marko.
thank you too.